No, check the equation that you use. I suspect you used the wrong one. The one that you use a bit ideal, but you need to use according to the design handbook, including the K value, the efficiency for motor, efficiency for fan. You need to consider that. If you do not consider that, then you might not get the final air speed that you need. Okay, so okay, later lah. That one we settle dynamic first. Okay. Okay, recap. So now we are at the curvilinear motion. And the object is moving in the curvilinear line. So we are now focused on the object. Previous section, we focus on the global axis where you use x and y. But this section, we focus on the object. So when we focus on the object, we use tangent and normal. Okay, tangent, normal direction. So normal always pointing in according to the curve. So use your palm. The face of your palm is actually the normal direction. And then the tangent direction always 90 degree, same direction as your speed, as your velocity. Remember that. So all the calculation, we are focusing on tangent direction. Okay, for example, previous class, we stopped at these slides. So we have acceleration, you have tangent direction and normal direction. AT, this AT magnitude, how you get AT magnitude is from the velocity. You take velocity equation, differentiate with time. You do differentiation for the velocity equation, you get AT. And the V here, you are using tangent direction equation, VT direction equation, or the velocity that's given in the question. How to get AN? AN is given by this equation, V square over rho. So how do you get V? This V is also used back the tangent direction velocity. How to get rho? Sometimes the question will give you. If the question do not give you, you need to calculate by using the equation. So this will be the important slide for curvilinear motion, where it focus on the object motion, on the object that moving in the curve. Okay, so every time you calculate the AT and VT, AT and AN, once you have these two, you need to do the magnitude calculation where you square the AT and then you square the AN, you square root it. This is the normal steps when you see object moving in the curve. Okay. Okay, last lecture we go into this. Already discuss this one. Already discuss Okay, so this one already find the direction, and this one you need to memorize because this one is part of the marking scheme. We want to give you marks for this equation. So if you give this equation in the question, mean this one have no marks. Okay. 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 This one is your homework. You go and read this one. This one we already discussed. Okay. So this one you have a view. This one also. This one is the combination of rectilinear motion plus the curvilinear motion. Yeah. Okay, we already done this too. Okay. Now, previously we have x and y axis, and then we move to the object. We have tangent normal. In mathematics, you know that direction of vector we can define in polar unit. Now we look at polar unit with angle, right? So this one we go very fast because I don't think I will ask you in polar question, but it's part of your syllabus, so we still have to go through. So when you define your collinear motion using cylindrical component with this polar unit, so we are using r and theta. R and theta. So basically, we are recycling what you learned, and then we change some of the parameter from tangent normal into r and theta terms. Okay, so the rest you read from the slides. Well, I'm going to show you the final final equation. As you can see here, when we use cylindrical component or polar coordinate, you see that our direction is the radius direction, UR, and the angle direction. We change R and theta. It's not tangent and normal anymore, so there's a bit different from the previous one. Tangent normal is focused on the object and the direction of V and the curvature of the curve, which is pointing inside the curve, N and T. But when we use cylindrical component, we use another set of coordinate system with this R, radius, and angle. Okay, radius and angle. So this one I go very fast. This one you read through. Is from the, it's not necessarily horizontal, but it can be a road, it can be something that is flat. So like one final question we asked before is, there's a real line, Greta P, that is crossed like this. And then the Greta P turn somewhere else lah. Okay, so this one you read. I'm not going to test you. What is important is the rest you read lah. It's actually recycling the vector diagram and all this, right? So now by looking at this vector, even though I do not explain it, but by looking at this yellow color triangular, you should able to write vector equation, right? The origin is here. So you follow the arrow, UR plus delta UR is your process. The U comma R is your result. So the result will equal to the summation of UR plus delta UR. This is what you need to know how to read. Okay, the rest you read. At the end, we arrive at one vector equation, which is in R direction, which is on the radius direction, and also angle direction. Okay, and angle direction for cylindrical is anti-clockwise positive. Anti-clockwise positive. The angle is positive like this. All right, and the positive of R is always from the origin to outside. Okay, and the rest you do differentiation, you get acceleration. Yeah, you differentiate the V, you get acceleration. So I will skip this one. So this is what you need to memorize if the question asks you about cylindrical component. This bracket equation plus the magnitude. Magnitude always take the front component square, behind component square, square root. Okay. So here I just compare side by side. VR you remember as R dot. R dot means position or S dot. Okay, VR means you take the R and then you differentiate with time. Means you'll be given R equation. And then the V V theta, velocity. How you get V theta? You get from R and multiply by the angle time differential. Means you will be given a angle equation. You take the angle equation, you differentiate with time, multiply by the R. This is two set equation that is in the cylindrical component. This just need to memorize lah. This one and this one. Yeah, this one and this one. Acceleration will be repeating the same. No need to remember, but if this question come out, I will give you the equation. Because this is a bit lengthy, I don't expect you to remember. But you have to know what does it mean. This one, R double dot, means you double differentiate the R equation. RU is just a unit or direction of R. You just copy this one. R dot means you differentiate one time. And then this one, U R dot is another differentiation, and so on. So basically, this one I won't ask you lah. I won't ask you, but it's inside your syllabus. It's a big, long chapter, but I think it's a bit taxing for you guys. Okay, so this is the slide when it comes to acceleration calculation. So your AR is equal to this bracket things. Okay, if the question asks you to find acceleration in R direction, you just use what inside the bracket to calculate. You'll be given R equation, you differentiate it double 2 times. You're given the angle equation, you differentiate 1 time and then square it. Then you minus the value, you get AR. Then this one also same, A theta equal to this one and this one. So you see double dot means you double differentiate the theta equation. Usually this one will be 0 after you double differentiate. R and theta, this one also differentiate 1 time, differentiate 1 time. Okay. And then this one is the same like the previous one, finding the magnitude. You square the x component, square the y component, and then square root. So basically you take the front square, take the back square root it. Okay, then when it comes to 3D, this one you'll see in your simulation later in your senior year. So if there is if there is a 3-dimensional direction, then you have RP defined by this equation. Velocity, you have R direction, theta direction, and Z direction. This is what you need to understand. I won't ask you 3-dimensional question in dynamic because it takes you a lot of time to calculate the equation. Okay. So this one later you can copy the answer on my slides later. All right. Okay. Now observe. Just observe the step. What we do when we solve cylindrical issue or cylindrical problems. Okay. How you know it's cylindrical problems? In the question, you will see something like this. Theta, double dot, or theta dot, or R dot. Then it fall under cylindrical section. You need to use these slides. Sorry, not this slide. These slides. And these slides. The calculation for V. This one. Yeah. You need to use these slides and also these slides. These two slides only. Okay. Okay, so I'm going to show you. Just observe how to solve. You are given an object, move in the circular motion, and you see the question are given in the theta dot and theta double dot. So this is under cylindrical position. So what you do, you go to the question, put in the axis, R. First step, go to the object, draw the R axis, means from the center to the object. This is the positive direction. And then the theta will be this direction. Okay, so with this direction. So you have theta dot and theta double dot. Okay, what mean by theta dot means the turning rate. The turning rate of this chair. Theta double dot is acceleration turning rate of this chair. Because it's double differentiation. Okay, single differentiation is speed or velocity. Double is acceleration or angular speed, angular acceleration. Okay. Now, once you know how to draw the axis, important, draw the axis. R is from center to the object, and then know the direction will be given in the question. Then you label. You only need to label the red color arrow, and then theta dot, theta double dot. Okay. You'll be seeing the object like this. R and theta. Positive in this direction, follow the motion. Follow the motion. R is positive, go out. And then you need to put in the normal and tangent direction also. For cylindrical question, you need to combine the normal and tangent label in the question. Okay, then observe. After you have the R is constant, you calculate the R dot. If it's constant, you differentiate a constant value, you get 0. Because fixed, the radius is fixed. So when you differentiate with time, equals 0. Once you get differentiate 0, you get double differentiation, you also get 0 because you differentiate 0, you get 0. And then you go and label. Your velocity always tangent to the curve. Velocity always follow the tangent direction. And acceleration, here is you calculate the A theta because the question is theta question, cylinder question. You label A theta. And AR, go inside is minus because positive is going out. So your AR is negative, going that way. So recall the slide that I showed you just now. So you call out the V equation. If this question come out, you're going to given you in the appendix page. So you just need to use this equation. Okay. Substitute the value only. R dot means from here. You're given the R equation. Differentiate one time, substitute here 0. R theta dot, you need to calculate. All right. And these are the 4 equations when it comes to cylindrical question. Okay, these are the 4 equations. It's important. Yeah. So here, you arrive at this one 0. So V will equal to this term, R theta dot. Okay. V equal to R theta dot in what direction? In angle direction. Here also same. R double dot 0. You cancel. You arrive at, okay, R dot also 0, so you cancel. Then you copy the answer. You arrive at minus R theta dot square. Basically, if I ask you this question, it's very easy to score. You just need to follow and give me these 4 equations, and then you differentiate the R, cancel the R dot and R double dot in the equation, substitute back the equation, then you get the answer. How you get R double dot? You differentiate from here. You differentiate 0, you get 0. Just careless mistake is here because AR is negative. Remember to put the negative sign here. Yeah. So R theta at this component equal to R double dot theta. Yeah. So I repeat one more time. The steps are, the step for cylindrical is to draw the axis first. First, draw the R positive direction. Draw the angle direction, the angle axis, the direction of turning, label theta dot, theta double dot, and then focus on the object. Put in the tangent and normal direction. Once you have that, you call out these 4 equations. Call out these 4 equations. Okay. Then you go back to the equation, the question. Sometimes you'll be given R, sometimes you're given theta. So if you're given R, then you do differentiation. If you're not given R, you're given theta, you do theta differentiation. Theta equal to theta, then theta dot equal to the equation, the differentiate one time, then you do theta double dot, you differentiate the previous one, you get one answer, substitute back to these 4 equations, then you get the answer. Yeah. Okay. Now, this question also same. We try to observe the steps. Now you read the question, how you know this one is cylindrical direction, cylindrical question. You read the question, you see theta, you see R in the question, means I was asking you on the cylindrical coordinate question. Same step. No matter how the question asks you, you read and then you try to imagine the motion. What actually the scenario? Rod OA, rotate OA. This one rotate this way. And remember, you need to see the question. Sometimes it's pointing to you. Remember to observe the arrow. So this arrow is going this direction. OA swinging this direction. On the horizontal plane, theta is given in radian. At the same time, in this case, if you see theta and R, you are having the unit of radian, not degree. So you need to know how to convert angle to radian. Okay, 180 equal to how many radian? Okay, 360 equal to how many radian? 2 pi radian. Then you do the calculation. Okay, so 1 degree equal to 2 pi divided by 360 radian, or you're given radian, you work back 1 radian, you move back 360 divided by 2 pi theta. So it depends on which one you want to convert. Okay. But anyway, you observe what actually happens. So at the same time, collar B sliding outwards, B is sliding outwards. So you have 2 objects. One is the rod, one is the ring. Okay, so that R is equal to equation, meaning this R, this radius of ring, is in the quadratic equation, but you don't need to worry about that. Both case is in T is in second, determine the velocity acceleration of the collar. You are focusing on the collar. You're focusing on the collar. So if this is the collar, okay, this is my collar. So you focus on collar, not the rod. You focus on the collar and you imagine what is the motion. So the motion, this ring is going like this, right? This is the theta direction, right? It's swinging like this. So you are focusing on the theta. So it's going this direction. And then the R, the R direction from the center to outside, always like this, R. Once you have established this one, you put in the axis. Okay? Now you know normal is going in, tangent, following the motion. Follow the motion. So this is your tangent direction. It's the same direction as the theta. Okay, always tangent to the curve. Theta also tangent, also like curve lah. Okay, in this case, we're not focusing on Z. Because the question asks you, it already tell you in the horizontal plane. So you only involved with R and theta. Once you agree with this one, the next step is to call out the four equation. V one side, A one side. Okay, and then see what equation you have. So inside this V and A, you have theta dot, you have theta double dot, you have R dot and R double dot. Here you are given what equation? You are given theta equation and R equation. So basically, you write theta equal to one equation, R equal to one equation, and then do theta dot one time, theta double dot, you do differentiation. This is mathematics. Then R also same, R dot, R double dot. Once you do differentiation, substitute back into these four equations. Or even I can say only two equations here, but I mentioned four because it's more clearer when you substitute. Four equation, usually this kind of question I will give you. Because I won't expect you to memorize so many equations. But there's no marks for the four equation. Once I give you, there's no marks for that. Meaning the question will be more complex if I do not give you the equation. Yeah, so these are the steps basically. Okay. So you observe. So I draw the axis. You can ignore the blue line, but basically it's in the collinear motion. Then we put in the V and R direction. And then there is an angle of gamma here to represent the change of V. There's one more small delta delta. Small delta here. Not gamma, it's delta. Okay, so any question on this diagram? Make sense to you? Does it make sense to you? Yeah. Important that you know how to draw the axis. What you need, what information you need to solve this kind of question? Axis, angle, R, theta, and then the tangent and normal direction. Okay, so you do the differentiation. This is just to find what is the value when it's 1 second. The question asks you 1 second, but it's okay. You do not do the substitution yet. You derive the equation of R dot first. So R dot, what do you get? 200t. Who don't understand why 200t? Anyone have question? Why R dot equal to 200t? Who don't understand? Okay, understand? So this one, 100 mm, 100 mm per second. This is when you substitute 1 second inside. This one later. All right. But important is that you understand you need to get the R, you need to get the R dot. And then one more, R double dot. When you substitute, when you differentiate 200t, One more time, differentiate, what do you get? R double dot, what do you get? 200. Okay? So just remember what information you need and then the unit. When you differentiate one time, you have over 1 second. You have differentiate double time of your time, you get divide by second square. These are the important information. Once you have the R, you do the same for velocity. Not velocity, angular velocity, theta. Do the same also. Okay, do the same. Theta, T3, T cube. You do what? Differentiate one time, you get 3t square. Okay, 3t square, you can ignore the substitution at this moment. Okay, then you do double differentiation of your angle. What you get? You get 60. Makes sense, right? 3 move to the front and then 2 minus 1. So you get 60. Okay, so you have 6 unknown, you already solved already. Means you get the R, R dot, R double dot, theta, theta dot, theta double dot. Substitute inside the 4 equation accordingly. Okay, now when you substitute inside the equation, this is the first 2 equation. R dot, you read from the answer when it's 1 second. So you substitute inside the R when it's 1 second. Okay, when it's 1 second, you substitute inside. Or you can develop the general equation first, then you substitute t equal to 1. You will get this answer. Okay, now the UR and U theta is a unit, you just copy. It's a direction unit like your IJK in the XYZ coordinate. This is just a unit. Okay, now once you have the V, you call out another 2 equation, then you substitute inside. Okay, magnitude, you know lah, square the front, square root, standard. Then you do the same for acceleration. Once you have the magnitude, you can calculate the angle where you read from your diagram. So how you know the delta? Tangent of this angle. Tangent is opposite by the side. Your opposite is V theta. Side is your VR. So inverse tan, your V theta divided by VR, you get this value. Okay. Now, however, this is only delta. You need to add this original angle with its theta. Okay, how to get 114? Because at 1 second, what is your theta? 1 radian. Theta equal to t cube. In 1 second, you get 1 radian. 1 radian equal to 57.3 degree. How to get conversion? 360 degree equal to 2 pi radian. You convert 1 radian into angle 360 divided by 2 pi. You get 57.3 degree. Okay, so here plus here. So total is 114. This is how you solve. Boleh. Okay. So you do the same for acceleration. So acceleration, you look at AR is negative. Again, acceleration always going in. And theta that way. So recall the second set of equation and then substitute only. Because second set, you have R double dot, read from your previous answer. R dot, read from the previous answer, substitute, and you get the answer. We will get this one. This is a vector equation in R direction and theta direction. Okay, this is mathematics. I just you just observe the steps. Once you have the direction, you can calculate the magnitude, which is square the front, square root, and then go to the diagram and calculate. Okay, go to the diagram and calculate the angle here. Tangent of this triangular is opposite by the side. Opposite is A theta, side is AR. You inverse the tangent, you get one value. However, this one you need to add this angle, the body angle. Need to add. Add to theta, which is 57.3. Because as you swing the ring, it's going to become larger and larger. This one will become larger and larger. This one plus this one. Uh, 57. One. Is it wrong? Hold on. Okay, maybe the value is wrong, but the concept is correct lah. Okay. Okay. Now we move to the next section. Already done, we already done on the curvature motion already. So curvature motion, you have motion, you have rectilinear motion, x and y, straight line. And then we move to collinear motion. Collinear motion, you have two axes. Collinear motion, you have tangent and normal. And sometimes you have your global axis, which is x and y. And then just now we see some cylindrical coordinate, which is we'll add in the theta and r direction. Now we move on to absolute dependent motion analysis of two particles. Now, just now, all the question we look at one object only. Now we look at two objects. When two objects moving, so there is a changing of distance and velocity. And this kind of question usually asked to avoid collision. So collision is always a challenging question in aerospace, especially on a space. We try not to have collision, or sometimes we just want to have chun collision, means we want to touch and stick like a magnet. Means we control the speed and then touch, and then the magnet will snap. And not like very hard bang like that. Okay. Okay. So now we look at pulley system. This question is my favorite actually, and it will be coming in your test one. The test one I already ready the question, so this one sure come out sure come out. So it focus on two objects. So, but I think if you have a simple logic, you should able to solve this kind of question. Okay, I draw something on the object. Okay. Now, on the whiteboard, you see two objects, right? Every time you see object, what you need to do, I will request for free body diagram. Yeah. This is not inside my slides, but what I expect in your answer, every time you see an object, or in this relative motion analysis, or an object that is touching the floor The first thing I want to see in your answer is you'll be given mass. So when there is a mass, then there will be W. Mass always focus on center of the object. So start from today onwards, all your answer, when you see object, I want to see you label where is the center of mass. I want to see a dot in your free body diagram. This is important. If I do not see this one, meaning your weight will be wrong. I don't go and very precise and not chun chun, I will minus mark. No. I want to see you put a dot in the center of the object. Cannot put anywhere. Must be around the center. Okay. If you put somewhere like this, I will ask a 3-year-old boy, boy, you come, do this dot center or not? If the boy say no, then no marks. If a 3-year-old boy can tell you where is the center, then you don't simply put. Okay, so free body object, first is the dot. Second, I want you to draw the weight along this line. It can be like this, or you can move your weight like this. There are two presentation way. One is pointing towards the point, or from the point pull down. Okay, or you can draw a dot line like this and put above along the line. Why? Because in your static, all the force can transfer along the axis of action. Okay. I ask you to put the center of gravity, center point, is to remind you that actually there's a mass effect under the gravitational. I don't want you to miss this W. When you see object starting today, put in W. Beside the arrow, you write W equal to mg, you get 1 point. With the correct direction. Either go inside the object or outside the object or above the object, as long as it's along the force axis. Yes. Depend on question. Okay. Now your test 1 question will be, you need to solve by developing general equation. I won't give you value. I will give you the m. I will give you the g. The length I'll give you. You just substitute inside the equation. Okay. Now, first is W. Second, if the object touching any surface, there is a normal force. Put an arrow pointing to the center or along the surface, anywhere also can, as long as it's pointing to the bottom of the object. But I always prefer you always align with your weight. This is normal. And the effect of this normal force, it depends. If the question asks, if the question mentioned is a smooth surface, no friction, means the mu friction is 0. If the question do not mention smooth, usually I will put a rough surface, then there is a friction force. Friction force direction is also important. That's why before you draw friction, you need to draw the motion of the object. So let's say this square object move to the left and you put a V there to represent velocity and also acceleration. If the object move to the left, where is the direction of friction? Is always opposite of the motion. So you need to draw the arrow opposite the motion and write this one is F small friction. F sub F to represent friction, and you write equal friction coefficient, and since you are in the dynamic, you use kinetic friction N. In the static, your mu is S. If the object do not move, then you use mu S. If the object is moving, then it's kinetic friction. Okay. Now, in your final question, it will ask you a question like, what is the minimum force required to move this object? So you need to find mu S before it moves. Yeah. Before it moves means static, you use mu S. When the object start to move, then you use mu K. Kinetic moving. Okay. So this is the general things that I want to mention. One is W. Write W equal mg. Arrow pointing to the center along the axis, no matter where you put also can. As long as I see there's arrow represent W. And then continue with the normal force as long as there's a touch surface. If there's no touching surface, some object hanging in the air, there's no surface, then no N. No N. So as long as the object have the surface touching and the surface is rough, then you have the friction force mu Kn to move the object. Okay, this question pulley is hanging to the a rope. When you solve rope question, you need to imagine you are the hanging object. If you are the A, where is the direction of tension? If you are A object, what do you feel? The rope is what? Pushing or pull out? Pull out, right? It's pulling your hair, right? So what you do? You go to this object, draw the T up from the object. Okay, the tension is what you feel. You imagine your object A, what do you feel? If you feel something pulling, then arrow is pointing out. If you feeling the object is pressing you, then arrow is pointing in. For object B, if you're B, where is the direction? Pull out, right? From horizontal. So your T is horizontal. These are the things that you need to master before we go into solving the question. Once you have this one, you understand this one, you can solve. This basically is equilibrium question. F equal to ma question. Understand? Okay, we have 10 minutes to solve this part. Okay. Another logic question. You have A and B. If B heavier than A, what happened to A? If B heavier than A, what happened to A? B heavier than A, what happened to A? A move or not? Why maybe? If B is heavier than A, so MB is more than A, means what? If you let go of A, does A move? No, right? So there's no motion here. Yeah. 8.5. Will it drop? No. If you live on Earth, if something heavy on the top, you let go, A won't pull. A will pull B, but it not have not enough force to pull B. Okay, I give you a let's do in a force equation. If we have 10 kilo of B, 5 kilo of A, how much force to pull B? We convert kilo to Newton. 1 kilo equal to how many Newton? mg. So you get 9.81 Newton to pull B. If you only have 5, how many Newton? Sorry, 10 kilo is 98.1 Newton to pull 10 kilo of object. Here, you only have 5. 5 means 44 point something. So you're pulling 44 point something. Will it move? No. Not enough force to pull. Okay? So these are the common sense you need to know. Will the object move or not? If the normal logic you cannot do, the rest question answer will show wrong one. Because you don't know the direction. So this is a common logic. If you live on Earth, heavier object will pull, and is much heavier than the previous one, it won't move. If it won't move, then it becomes a static question. Static question, everything equal to 0. Then you balance the system. Okay. Okay, now, if you understand the motion, we put in some parameter. For the two particle question, what is important is this word, datum. Datum is your reference point. Without datum, you cannot solve this question. So first, when you look at a question, you need to identify what is your datum. Datum is your reference point. And always you will see the question will give you direction of the datum. Meaning, if you look at the object A, SA positive, go downward. B, go downward to the right. So this one. SA you know already in the previous one. Is the distance traveled. Displacement. Okay. Okay, the rest is okay. So again, if it's A and B same mass, the object won't move. If A is heavier than B, A will pull B. A will pull B. What is the sign for SA? Will be positive or negative? Positive. If A is heavier than B, A move down based on datum, SA positive, but B will move up, so SB will be negative. So this kind of question, again, datum is important, direction is important, and then the logic motion is important. Okay. The rest read. Okay, you have to label where it's a positive. It's important. Okay. Now, another simple mathematics. There's one constant value in the pulley system, which is the length of the rope. The length of the rope doesn't change. You know how to calculate the length of the rope, right? The total rope length, how do you calculate? SA plus CD plus SB is the total length of the rope. Correct? Correct? Okay, once you have the total length, you have 3 components, and you want to find the change of the rope. Okay, and we all agree, this section, the highlight red color, CD, do not change over time. No matter as A move down, move up, CD portion doesn't change, always same. So, if we time differentiate, time differentiate this equation, means dl dt dl dt, we get s dsa dt, dl cd or dt, dsb dt. We know that dl dcd 0 because it doesn't change over time. We can cancel. We arrive at this equation. Why 0? Why 0? dl dt doesn't change, the same rope, same length. That's why dl dt 0. That's why we eliminate this one. dl lcd dt, we do not have this one after the step because the doesn't change. Okay, we arrive at this equation. S ds dt, what do you get? Velocity, right? dt, that velocity, right? You can write va plus vb equals 0. Okay, so for this kind of question, basically is simple. As long as it can say SOPs fixed already. First, you write this equation, LT equal to SA plus LCD plus SB. Then you do time differentiate. dl dt, you arrive at this equation. Then you convert ds dt to velocity. This is the first 3 steps fixed already. When you see pulley question, you do these 3 steps. Derive the equation first. Then only do substitution. Yeah, give me another extra 10 minutes, right? Okay, so if you move this equation, VA plus VB equals 0, you rearrange the equation, pull the VB to right hand side, you get negative, right? Either you get negative VA equal to VB or VB equal to negative VA, it's the same. Now, recall back, this understand, this one understand, right? You move this one to another side, you get negative. It's the same thing. Okay. Now, recall we are doing vector. We are doing vector. What does this equation means to you? There's a question asked you, what does the motion means in your calculation? What is the direction relative between A and B? You need to answer this question in your test 1. What does it mean? This equation, what does it mean? If A move down, what happened to B? Negative sign. If B move down, A move up. So negative sign means there's an opposite direction between A and B. Because you are looking at vector form. Because you are tied to a pulley system. When you pull one object up, one object will down. If one object down, one object will up. It's a relative motion. This logic you must have. You cannot pull one object, 2 go down, cannot. Means you are not on the earth already, or you're using rope that is elastic. Okay. Yeah. So this is some understanding you need. Same with acceleration. Same with acceleration, because when you dB, dA, you time differentiate again this equation, you'll get this equation also. Yeah, back to this one. You differentiate dVA over dt, you get AA plus AB equals 0. So you still get the negative sign. Okay. Now, we start to apply a bit. You look at this system. You have object A, object B. Start asking yourself, if I pull A, what will be the direction of B? Will it go down or go up? If I pull A, B will go up. If I let go A, if A is less weight than B, then B will go down. Okay, this one you have to know. And then look at the datum. Look at the datum. Datum is on the top here. And observe the direction. B going down positive. A is from here. A datum here is here. So datum positive here. So from the derivation, you know there's an opposite direction between A and B. So don't simplify the minus sign. There's a meaning of minus sign. Okay. So try to observe. This one you read. You read. Okay. First equation, always start with calculating the total length. LT equal to something plus something plus something based on the diagram. So the total length of this rope equal to SA plus the red color section, but we doesn't care the red section because if you time later, this one will gone. So we're not interested. No need to write. Skip the length on the pulley. Just the length to the object. So SA plus H plus what? Part 2 SB. This one and this one. Okay. First equation, write the total length equation first. LT equal to S something 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 plus something something. Then the next step, differentiate it. Okay, differentiate it. Differentiate with time, L will become 0. dl dt will be 0. This one will be ds db dt. It will become velocity of B. H will gone. Because H will fix, because fixed already. H doesn't change. H will gone. Then this one, SA dt, you get VA. You get this equation. Make sense? Does the equation make sense to you? Okay, again, what does it mean? If A move, what happened to velocity of B? It will be faster 2 times than A, but different direction. Okay, means if either you pull or push A, B will go up, go down very fast. Yeah, this one it will be one part of the question in your test one. It will ask you relative motion, explain the motion. Same with the acceleration also. And acceleration negative here is the direction, not deceleration, not slow down. This is just the it's just the direction. Okay. So this is the explanation. If A move to the left, B will move downward double time, double the motion. Okay. Now, observe. What is the difference between these two diagrams? Spot the difference. What make the SB change? Datum change. Although the same question, but I change the datum, answer is different, totally different. Okay, so just now I give you the A diagram. Now I give you the B diagram where I change the datum. Datum now is going up positive. Just now, going down positive. You observe what is the step? What different in the final answer? First steps, we calculate the total length, right? How you get the total length? SA plus H. How you calculate this length? H minus B, right? This is the effect of datum. If you change datum, then calculation will be different already. But still, the focus is on the rope. You are more interested in the rope, how you find this distance. You take H minus SB. But just now, how you find SB? Directly use the SB because datum is from here. Yeah. Now, first step, always find the total length. Then you do time differential. You get velocity. You arrive at one equation. This is important. Get velocity. The next step is to write the acceleration. These three equation is important for pulley question. Always start with total length. Then you do time differential. I want you to see the relative motion between two body, velocity and acceleration. Okay. So what does it mean? If this case, the negative sign gone, but it still explain the motion, right? Because the datum is from ground to top. So if you move A, B will move up, right? So it becomes positive. So the positive negative sign is referring to the datum. Yeah. Once you understand this one, I'll show you one tutorial question. You should be able to answer why they are same, because the motion is following the datum direction. Yeah. All right. Now observe the tutorial question, and then we can dismiss the class and see you tomorrow. Now the question asks you determine the speed of A. A block B is upward speed is 6 meters per second. Observe the question. If you move A upward, what happened to B? Upward. If you move B, what happened to A? A go down, right? If you move B, A will move down. Okay. Observe the datum. Datum, as A go down positive. So later you will get negative sign for A because A move up, A down. So you get positive sign for A. B, datum you need to check. SB go down positive. So your B will be negative because you move up. This is what you need to check before you solve question. You need to see the motion. You need to see the datum. Watch, just observe the steps. Ignore the mathematic part. Observe the steps. First, always we write the total length. Okay, datum I skip already. Datum, check the datum. First step, write the total length. How you get the total length of the rope? You start from, okay, this one, highlight for you is you not to calculate. This one is fixed already. So you get SB plus SB plus SB plus SA. This one is can change one according to the question, but what is important is to find the total length. Once you have the total length, you time differentiate it. So L becomes 0. dL dt 0. Total length doesn't change. SA become VA, SB become VB, SB become VB, SB become VB. So you have this equation. Then you time differentiate, you get this one. Agree? Then important is to move one term to the left. Either you move B or move A, doesn't matter. I want you to show me this equation, and then you can calculate. PB will be 18. This is actually the steps. Basically, is quite easy to solve this kind of question. What is the careless mistake if you do not observe the datum? Okay, the rest is your homework. Go and see. The answer is there. The answer is there. And this one also same. This tutorial question, what is tricky is the angle. The rope is, you need to solve trigonometry equation. Go home and observe this, study these slides. If you have questions, come and ask me. This will be your final exam standard. Okay, go home and read this example. I show you the derivation also, quite lengthy. Next lecture, we go for 1.8. Okay, we stop here. Okay, see you guys tomorrow.